Hi, my name is Diego. I'm a Senior Solutions Architect in AWS, and I'm specialized in migrations. And on this session, I want to highlight what types of legacy applications and associated factors that will make a good candidate to be migrated to containers. And I will also discuss some of the best practices and some of the application changes that have to be taken in consideration as you embark in your migration journey. So, the legacy application. As part of your enterprise migration journey, you'll probably find some really interesting legacy applications that happen to be running in your data center for years. And legacy doesn't necessarily mean old, but applications that are existing and they are in production, and they are an important component for your business. So, assuming some of these applications were built years ago, it's probably that they could have some very interesting design pattern or architectural decisions that were made before cloud existed. And some of these applications will be totally fine if you decide to migrate them to AWS using a lift and shift approach, like using Cloud Endure, SMS, or maybe VMware Cloud on AWS. And all that has been proven to work. And there's some benefit related to this lift and shift approach. But at some time, you would like these applications to evolve. And during your migration planning, somebody from your team might just come with this really good idea. Let's containerize this application. Yeah, it sounds really a good idea, and on this session, I want to explore some of the application patterns and characteristics that would make a good candidate to become a container, as well as some easy modifications that you can apply on your software to turn it more container-friendly, as well as some of the challenges that you could face during this journey. So I hope you enjoy. Well, so why does it sound as a good idea to put your legacy application in a container? That's because you might have the impression that by default you will inherit all the great benefits that operating in a container environment would provide. That you can increase your agility by developing and deploying faster, newer versions of your application to achieve your business goals. Or that your applications are going to be portable and you can run in any container-compatible environment. And that you are also going to be able to scale this environment and keep your applications isolated from other applications. And that you can reduce your IT operational overhead to achieve optimized compute infrastructure, because containers, generally, they might use less space than a virtual machine, and that require few virtual machines or operating systems to manage. And in some cases, you can squeeze more applications per server. Yeah, although all those benefits are true, they can only be achieved if you understand the following. We're talking about legacy software, legacy applications, and legacy software that they have been built years ago using some architectural patterns that are not really cloud-focused. And these applications, they would have to evolve. Some architectural decisions that you've done in the past, they should not be repeated in the container world. I would include as well the lack of domain knowledge on legacy applications, because sometimes people don't remember how that application was built or how to install that specific application, or you don't have the source code anymore. That could be also part of the problem, which includes legacy platforms. You might be running on some unsupported older version of a Linux OS or Windows OS, some legacy version of Java or Tomcat or .NET. That will also have to evolve. And connecting to that, your staff. So your staff is busy with their day-to-day operations, and not necessarily they are experienced into container technology. So there will be a learning curve, which affects operations, because operating in containers is slightly different than operating on a virtual machine. The way applications are deployed, the way you connect to these applications for troubleshooting, your backups, everything changes. So to achieve all those benefits mentioned in the previous slide, it's really important that you select the right applications that should be containerized. And to invest as well in your staff to learn container technology. Well, now that we understand the challenges and also the benefits about moving to container, Let's talk about the 4 steps that would have to be followed to migrate your legacy application to container. The first one is to discover and understand how application works. And then, if you have multiple applications, select and prioritize what applications will be containerized. Then you have to prepare this application before creating the container, or make some small changes in the application to make it more container-friendly. The third step, you build the container and you have to publish that in a container repository. And finally, you have to launch the application and put the application to operation. It's important to mention that there are a lot of tools in the market that can help you with all those phases, but I want to highlight AWS F2 Container. So in July 2020, AWS released AWS F2 Container, or A2C for short. It's a command line tool for modernizing .NET and Java applications into containerized applications. A2C discovers and analyzes all the applications running on your servers. And you can simply select the application you want to containerize. A2C will package this application, artifact, and runtime dependencies into a container image. It can configure the network ports and also generate ECS tasks and Kubernetes pod definitions to be used to launch your applications. So for the preparation phase, I'm also recommending here that it's still something manual that you should want to execute because that depends on some factors and some other architectural decisions. Well, so let's get started discovering with the first step, which is discovering this legacy application. And for that, I'm going to use a pattern. I would call that all in a box. I'm going to use this application just as an example because it makes things simple. And let's pretend my legacy application is composed by an older, unsupported version of Linux, Tomcat or maybe Java running some older version. I have a database that happens to be running in the same server. The way I deploy this application is manual. I have to log on into the server and manually copy files and put the files in the right directory. This is just an example. But it could be the same principle if you're using Windows or Linux or different applications. The important part is, does it sound any familiar to you? I mean, virtual show hands if you've seen this architecture before. Well, how can I translate my application into something that's going to be more useful to containers? Or how can I have a more prescriptive discovery so I can determine if I have a good candidate for the migration? And you can run a simple discovery script, there are really a lot of good tools in the market that can help you to automate the discovery. And F2 Containers is one of those, which can detect your application and the application dependencies. But I'll focus here on the more conceptual principles. So I'll start with how your users consume this application and what network ports are in use, what protocols are you using. It's a web application using HTTP or is it a TCP, UDP based protocol? Do you require to have encryption on that application, SSL or any other kind of encryption, or maybe a proprietary protocol? This application might have or not a platform. By platform, Tomcat, JBoss, WebSphere, IIS. Is there any schedule task that requires this application to work? What's the underlying operating system? Well, really, the focus also should be more towards your application along with these other questions that I just made. So how is this application? Is it a compiled application? Is it a script application like PHP or Python? Do you have the source code? Not that the source code is a requirement to become a container, but it helps a lot when you're making these architectural decisions. Where is the configuration file? Is the database connection defined into this configuration file? Where do you store the passwords to access that database? Is that information in the configuration file as well? And where does this application save data? For example, if my fake application, it has a folder where I upload documents as part of this application functionality. In what folder am I saving this data? And how this application handles sessions? Is it a stateful session, a stateless session? Can it operate behind a load balancer? without you having to worry about sessions management? Yeah, I know it's a lot of questions, but that's for a reason. The answers will help us to drive the migration path and strategy. So once you collect all that information, we can use this diagram to understand and baseline the challenges that we will have to address while creating the new containers out of this legacy app. And I will demonstrate some of the factors that can be considered when selecting and prioritizing an existing application. My recommendation is that start with the easy ones. Select one that has a modern development language where you have the source code, and web applications are generally easier to go to containers, especially if they have a stateless, if you have a stateless application. And also where you're saving data into a single folder and you have only one single configuration file that you need to modify for that. And as you get more experienced and confident about containerizing applications, you can start moving to the more complex applications. Some other advice I want to get to you, just because you can do it, that doesn't necessarily mean you should do it. And evaluating this application is a must-do for just about any application. So if you do determine that it would have a real value in moving this application to a container, then you have to measure the effort to achieve that outcome. Now that you discover and understand the priority of what applications are going to be containerized, it's time to make some adjustments into this application so it becomes more container-friendly. And I will start with two basic container concepts. First one is containers, they should be portable. That means you might want to distribute or use the same container in your test dev environment, or if you're a software vendor which you want to distribute your container, you want to use exactly the same container image. So that means creating a container without usernames or passwords or connection strings to that container. You want to make it flexible and portable. And do not include any other dependencies like your database, because as a good practice, each application or each component of this application should be put on their own container. And the second factor is containers, they are ephemeral. So that means they can come and go, scale or not with your app, and being terminated as part of this scaling mechanism. And with that being said, you should not store application user data in the container. And that includes your database data, logs, any other kind of user data. That data, it should be saved externalized from the container. And I will show you some alternatives on how to do it. So if I cannot store my database connection string in the container, where should I store it? Well, one of the most important principles in containers is to pass the parameters to the container during the container launch, such as connection strings, credentials, other parameters. And that's achieved by using environment variables. There's some other architectural decisions that you can select, for example, sidecars, but for this session, I want to keep it very simple. So when you launch a container with your application, you have to create a deployment configuration or a task, depending on your container technology. As you can see here on number 1, where you can define parameters as the database name or database host name. And this container platform will use this information to inject those values as an environment variable in the container. One of the benefits about using Amazon, one of the container offerings in Amazon like ECS or EKS, is that you can use the parameter called value from. So you can store your parameters securely in AWS Systems Manager parameters or AWS Secrets Manager without having to worry about passwords being shared as plain text. And when you launch this container that has your application, as you can see here on number 2, the parameter will be presented to the container as a variable. So your application, on number 3, can read that information and use that properly. And for that, there's some changes that you can make in your application that are easy to manage, or especially if you have the source code. On my left side, you will find a hard-coded approach. Username, password, IP addresses, everything is hard-coded in the source code. My recommendation is that to change this approach to what you see in the other side, where you tell the code to get a specific system environment, db_name, for example, and that will give you some freedom to connect to a production or to a test database without having to modify your source code or create a new container every time. For applications that read that information out of a configuration file, a different approach can be used. On my left side, again, simple configuration file, everything is hard-coded, my username, password, database, IP address, connection strings. What you can do here is to modify this configuration file and replace some strings, replace it with some strings that are unique. For example, env_db_name. And then you can use a script using Unix sed, for example, to replace that string with your environment variable before you start the application, as you can see on this green box. So you can replace your environment variables that the container is receiving from the task definition, ingest those values into the configuration file, and then finally launch your application. Some other modifications that you can do in the application prior to containerize it. By default, Docker shows the command line outputs as if you're running a command in a terminal. If we use the Linux case, we're talking about the standard std in, std out, and std error outputs. The good thing is there is one Docker driver that's called AWS login driver. And that driver will send those logs to Amazon CloudWatch logs by default. But what about your application level logs? Well, a quick fix that you can do is to create a symbolic link from the log file that your application saves into one of those I/O streams. For example, you can link var log my app log to dev std out. And how to address this storage data situation? So why not leveraging the existing nature of this application writing files directly to the operating system? You would have to know in what path this application saves files, and you can use Amazon FSX for Windows or EFS for Linux, and configure that in your deployment or configuration task, as you can see here in number 1. Again, my example, my application saves data into the /upload folder. So I can define it in my configuration deployment to mount my EFS volume with that specific path. And that will be mounted in my container, as you can see here on number 2. The application, number 3, will operate the same way it used to operate prior to be converted into a container, because it reads and writes files out of that specific path, which now is mounted externally. This is a really nice approach because it adds some features in your application like highly available and elastic file systems and external backups. Now that I cover how to discover applications and some quick modifications that you can make in your application to make it more container friendly, it's about time to build and launch your application. My first recommendation is that you spend some time learning on how to use Docker files to build a container. F2 Container can generate those files for you, but it's a good practice just to understand how Docker file works. On my left side, there's one Docker file example, and I just want to use some of these items to highlight. The first line is from base image. That's the image that will be used as the base for hosting your application. My recommendation is that you don't blindly trust any image that you download from the internet, as it's appealing it could be. Another factor is that when selecting this base image is to keep it very lightweight, because you want to, and of course only containing the bare minimum necessary to make this application to work. The next line, you can create the symbolic link to redirect your logs as to the right output file, as you can see, redirecting my log file into std out. And the next script is to invoke the command to replace the strings in that configuration file, the Unix sed screen that I mentioned previously. And finally, you invoke the entry point or the binary file for your application to start. On my right side is just an example of a deployment configuration on ECS, where I can define the log driver that is going to send logs to Amazon CloudWatch logs, and the environment variables that set my DB name, my database username, and also that my password is stored on a secured way using AWS Secrets Manager. I'm also telling in the last line on how my container should mount my upload path into my EFS volume. So as you build this container, you might choose the path of doing things manually, and that's totally fine, but why not doing that in a more automated fashion? This is just a suggestion, but F2 Container can create this workflow for you, where every time you commit a new code into a repository, as you can see here on number 1, it will build a new container for you on number 2 through a code pipeline. And finally, result, it will be storing that container image that was just built into Amazon Elastic Container Registry, or ECR, as you can see on number 3. And again, one of the benefits about storing your container images into Elastic Container Registry is that you can enable its vulnerability scanner. So every time a new image is published, it will automatically scan that image for you. Other functionality that F2 Container can provide is the capability to create CloudFormations that can be used to deploy your ECS Fargate or your EKS cluster, containing as well an Elastic Load Balancer. So the same image that F2 Container created for you on number 1 will be updated in the task definition of your Fargate, as you can see here on number 2. So as you already modify this application prior to creating the container, you can leverage some of the AWS services that can be integrated with containers, such as RDS, EFS, Secrets Manager, or Amazon CloudWatch Log, as you see on number 3, to deliver a modern, elastic, and highly available version of your application. As next steps, I'll start recommending select your AWS container technology, ECS, EKS, Fargate, or even manage your own container-based solution. Start selecting what applications you want to experiment as part of your migration journey, and to modify those applications to leverage some of the cloud-native technologies. You can also find some reusable patterns in your company. You can use the same base image, for example, a base image that contains the same OS or platform, and just reuse it across your other applications. And finally, if your application is too heavy or is not scaling as expected, start considering breaking this application into smaller applications, or breaking the monolith. With that, I finish here this session, and if you're looking for more content related to migrations, please check one of these links in this deck. That's all I have for today. I hope I've had a good time and enjoy your reInvent 2020.